Let's talk about the inverse trig function buttons on our calculating machine. So they're going to do the inverse operations like we've been talking about. Minus addition and subtraction are inverses. Multiplication and division are inverses. The inverse of an exponent is a reciprocal exponent. The inverse of an exponential function is a logarithmic function. The inverse of a trig function is going to be an inverse trig function. And we have buttons on our calculators that indicate inverse trig functions. Our notation is sine with a -1, seemingly as an exponent. That's a shorthand for an inverse notation. That doesn't mean 1 over sine. 1 over sine, we would use cosecant. We don't have that button, so we'd have to do 1 divided by sine. So specifically, how are these buttons going to work? Let's take a look at one of the problems that we have when it comes to doing inverses. So we run into a similar problem doing inverse trig functions that we had when we were inverting even exponents. So the problem is that when we try to invert, say, an x squared function, the square root of x function is not quite sufficient, because the function x squared is not a one-to-one function. There are 2 values of x that lead to 1 value of y. So x squared equals 4 has 2 solutions, +2 and -2. But when we ask the calculator, what's the square root of 4, it just tells us the +2. The calculator has to pick one to say this is the value. So the same thing happens here. Notice that there are 2 angles, there are 2 solutions on the interval from 0 to 2 pi, where cosine of x is equal to 1/2. Cosine of x equals 1/2 has 2 solutions on the interval from 0 to 2 pi. In general, cosine of x equals 1/2 has infinitely many solutions, because this is just one cycle of cosine, and there are infinitely many cycles of cosine happening every 2 pi units. So we do note that there are infinitely many solutions on the entire number line. But cosine of x is equal to 1/2 has 2 solutions on the interval from 0 to 2 pi. We know this by finding the reference angle and placing the reference angle in the appropriate 2 quadrants. It's like the first and the fourth quadrants. So our two, we have a 60-degree reference angle, which is pi over 3 radians in quadrant 1 and quadrant 4. So x equals pi over 3 in quadrant 1 and quadrant 4. So the 2 solutions are pi over 3 in quadrant 1 is pi over 3. And pi over 3 in quadrant 4 is pi over 3, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. When we ask our calculator what the inverse, what cosine inverse of 1/2 is, it has to pick one. The calculator has to pick one to be the cosine inverse of 1/2. So if we ask the calculator, what is the cosine inverse of 1/2? It will pick 1. Let's see, we're in degrees, so that's fine. It picks 60. It picks the one in quadrant 1. And it relies on you to know that there's another one in quadrant 4. So the calculator picks the one in quadrant 1 and counts on you to know that there's another answer in quadrant 4. Just like when we asked the calculator what the square root of 4 is, it said 2. The calculator is relying on you to know that there's another one, -2, other square root of 4. The same thing happens when we look at the cosine of x equals -1/2. We can see those two solutions because cosine is negative in quadrant 2 and quadrant 3. So cosine x equals -1/2 also has two solutions. On the interval from 0 to 2 pi. Infinitely many solutions on the entire number line like normal, but we know that cosine is 1/2 is going to be pi over 3 reference angle. And cosine is negative in quadrant 2 and quadrant 3. So this gives us two solutions. Pi over 3 in quadrant 2 is 2 pi over 3. Pi over 3 in quadrant 3 is 4 pi over 3. This is just stuff that we get to remember because we know our values. The same thing happens. The calculator must pick 1 to be the cosine inverse of -1/2. The calculator only gets to pick 1 to be the cosine inverse of -1/2. So if we grab our calculating machine and find the cosine inverse of -1/2, it picks 120. Oh, we're in radians. 2 pi over 3. And just like before, you have to know about the solution in quadrant 3. The calculator will tell you one of the solutions. You have to know about the other. Cosine of something is negative. We know we're talking about angles in quadrant 2 or quadrant 3. We can use the calculator to get us one of those. We should also note that our calculator is not giving us a reference angle. It's giving us cosine inverse of -1/2. So what we have done, like I was there, what has happened is that we've restricted the interval over which we will invert the cosine. We restrict the interval over which we invert the cosine to just cover the first and second quadrants. So we have all this cosine going on forever in both directions. As far as the inverse is concerned, we only care about what's going on in quadrant 1 and quadrant 2. Notice that those are the two angles that we got. The reference angle in quadrant 1 and the reference angle in quadrant 2. So as far as the calculator is concerned, cosine is only this part of the function in quadrant 2 and quadrant 1. If it's negative, it gives you the one from quadrant 2. If it's positive, it gives you the one from quadrant 1. So cosine inverse only applies to the interval from 0 to pi. We had to pick one quadrant where cosine is positive and one quadrant where cosine is negative. So we went with one with you, like I was there. I missed that meeting. Notice that the same thing happens with sine. There are two solutions on the interval from 0 to 2 pi where sine of x is equal to 1/2. Quadrant 1 and quadrant 2, that's where sine is positive. Sine is negative in quadrant 3 and quadrant 4. So we've got to pick one of those quadrants where sine is positive and one of the quadrants where sine is negative. We don't like not using quadrant 1. We definitely want to be using quadrant 1. Right? We definitely want to use this quadrant. The problem is quadrant 4 isn't attached to quadrant 1. That's really annoying. But I need one quadrant where sine is positive and one quadrant where sine is negative. Quadrant 1, and then I have to pick 3 or 4. The problem is 3 or 4 are both detached from 1, unless we remember that this function goes on forever in both directions. So instead of using this quadrant 4 way the heck over here, I use this quadrant 4 that runs right into the quadrant 1 that we want to use. I don't know why I'm double highlighting. So if I ask the calculator for the sine inverse of 1/2, we get 30 degrees. That's 30 degrees in quadrant 1 like we expect. If we ask the calculator the sine inverse of negative 1/2, we get negative 30 degrees. That's the 30-degree reference angle in quadrant 4. If we want that one in the first cycle, we just add 360. That's the 330 that we're expecting. But we had to pick two quadrants where one where sine is positive and one where sine is negative that are right next to each other. So we use the 4 that comes up before 0. So that's why the calculator is going to drop negative value. So that's why we're going to get sine inverse of negative 1/2 is negative 30. Oops. Now you might be thinking, did you just talk about this so you can talk about us knowing our values yet again? And the answer is no, 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 yes. It is 100% that. Question came up, are we going to talk about chapter 5? Chapter 5 is all about identities, and I'm not ready to talk about all that algebra yet. That's the purpose of doing all those trig identities. Make you better at algebra. That's why we're doing all this solving equations business, and it looks an awful lot like algebra. That's because it is an awful lot like that. Comment. On Thursday, we're going to talk about how we can combine all these inverse operations into a system for solving equations. That's going to do it for today. I will see you all on Thursday. Everybody grab a cookie on the way out if you would like one. I'll see you on Thursday, and thanks for playing.